my name is Malcolm.
No.
What we're doing this morning, we're going to talk about a topic which affects you all. At some point, every day, you'll come across it. Temperature. With temperature, we also need to understand how we measure it with regards to temperature scales. So we'll look at the temperature scales, we'll look at what temperature is, and we also need, because some of the appliances we use and the scales we use, we need to be able to convert those. So we'll see that later on, so I'll get you to do that later on. First of all, temperature then. Let's see what you know about temperature. Leah, first word that pops into your head when I say temperature.
Cold.
Neil.
Hot.
Hot. Well thought out.
Hot.
You've run out of options now.
Yeah.
Russ.
Good at Russ.
Summer.
Summer.
Reminds me of summer when you mention temperature.
Yeah.
Got to straight away think of the sun and the heat.
Freezing.
Okie dokie. Right. Okay. We'll keep those there for the time being. Let's come back to those later on, and we'll deal with them. First of all, what is temperature? Well, I've got 2 glasses of water there. Just put your finger in each one.
In.
Yeah, one at a time.
Okay.
Okay? What do you think?
Hot and cold, difference.
Okay, so we're hot and cold.
Mm.
We have a means that we can determine the temperature of things by touch. What temperature are those? You don't know really, do you?
No.
No, because you haven't got a thermometer. But to have a thermometer we need a scale, don't we? And for temperature to be any good we need to have some scales. But first of all, what do we mean by temperature? What is temperature? Any idea? Any volunteers?
The heat around us.
It is the heat around us.
Condition that affects our body functions.
It does. It does all these things. But the definition of it is the intensity of the heat. Okay. It's not a measure of the quantity of heat, that is measured in joules. But temperature is a measure of the intensity. So when Leah put a finger in there, she knew that one was cold and one was hot, but she didn't know what the values were. In order to do that, we need temperature scales. So, did you all listen to the radio this morning? And what's a very important thing that happened this morning when you woke up, you went outside to get in the car, what was the problem for us?
Frost right in the ice.
Okay, you had frost. And you could have determined that because when you listen to the TV, they would have told you something, wouldn't they? They've got to give you the weather. And they use a particular scale. Do you remember what scale they use?
Fahrenheit and Celsius. Was that?
That's right, predominantly we now use Celsius, don't we? Be interesting you talk about Fahrenheit as well. Okay. They would have told you what today's temperature was. You went outside, you'd have realised that the temperature was cold, there was frost on the car. So in order to determine that, we need to have a range of temperatures that we can use, that we feel comfortable with. And if we consider the Celsius scale, which Neil's already mentioned, which is the customary scale that we use now, and we have done since the 60s, it has a starting point, and it's got 2 reference points. Everybody know what the starting point is for the Celsius scale?
0.
0, but what determines that 0 point?
Freezing point.
Of
The outside.
freezing point of water.
I mean,
So the freezing point of water determines the 0 point on the Celsius scale. What about the upper point? That's the other reference point.
The boiling point of it.
The boiling point of water. Do we know what that is?
Gases.
Sorry?
Yeah, is it?
The boiling point of what the temperature
Is
is?
it 100 degrees?
No.
It's 100 degrees. Anybody know why it is 100 degrees? That would be really a subject of another lecture, but could you tell me why?
Round figure.
Sorry?
Just an easy figure, wasn't it?
It's fixed by the atmospheric pressure,
Ah.
okay? Atmospheric pressure depends.
Yeah.
If you, that's at sea level. If you went up Mount Everest and boiled a kettle, you'd get a cup of tea at about 60 degrees, because there's less air pressure. However, we can talk about later. Between here we've got 100 divisions. And so this morning they would have been talking about a temperature of about 1 degree. 1 degree C. In the summertime, it's British summer, we're talking about 15 degrees C. Go to South Africa, we're looking at 30 degrees C. But we've got a range where we're all comfortable with this. It's a code of a scale that we can use and we can identify with. That's okay for us, but in the science world, in engineering and physics, we need another scale. Anybody know what we use in engineering and physics? No? It has a 0 point way down there, and it's called the absolute scale. A gentleman, Bill Thomas, who later became Lord Kelvin, developed the scale about 100 or 2 years ago, and we have what we call, it's named after him, it is the Kelvin scale. It's that, because it's called the absolute scale, its 0 point is way down here. It's called the absolute scale because of one particular reason. Within this room, everything in this room, outside the room, in the universe, are made up of, any idea? What are we made up of?
Atoms.
Atoms, molecules and compounds. Okay. Now at these temperatures we're in today, although it's cold outside today, they still jiggle about. If you take the energy away from them, they don't jiggle as much. You get down here to what we call absolute zero, they don't jiggle at all. Okay, and that is absolute zero. And that's the starting point for the Kelvin scale. Okay, if you looked at it on the Celsius scale, it would be minus 273 degrees.
Tad nippy then,
Sorry?
yeah. Tad nippy then.
It is a tiny. Theoretically, or mathematically, it has been known for a long time. Practically, 2 Americans did it, well, they got within 1/millionth of 1 degree in 1968, and they got the Nobel Prize for it. So, 0 Kelvin is minus 273 on the Celsius scale. And of course, if we looked at, if the weather girl or the weatherman this morning was talking about, he'd have been talking about, well, today it's going to be 274 degrees. Not very good, really, is it? Hard to get your head around those sort of figures. So this is why the Celsius scale is a customary scale.
Can the atmosphere or whatever go no colder than minus 200? Is that the point at which
That can go
it's
no
as
cold.
cold as it'll go?
Within current scientific thinking, I've got to qualify that,
Yeah.
we can't get any further than that. Okay?
Yeah.
They've challenged the speed of light now because the neutrinos have found to be coming back at a different rate as they expected them to. They should be obeying the speed of light. That's in question. So the Kelvin scale then, so if we're up here, we've got, that would be 273, and if we're up, it would be 373 Kelvin. Scientific scale, we're at a scale, which is the Fahrenheit scale, which we've not really used a great deal since the early 60s. And though you will find reference to it in perhaps equipment you buy, and also occasionally they will talk about it on the TV. But generally speaking, we tend to use a Celsius scale now. The Fahrenheit scale is a bit unusual. It again, they all go down to the absolute point. It has 3 reference points. This reference point here is the 0 point. Bear in mind, this scale was derived by Fahrenheit, a German engineer, in 1724, a long time ago. The coldest thing that they could achieve at that point, they knew about, was a mixture of sodium chloride and water, common salt. If you do that, if you put salt on the ice outside, what happens to it? It melts. But so what it does, it lowers its freezing point. And that's what it was then. The lowest known temperature they could achieve was a mixture of salt and water, which was a phlegmatic mixture. And that became the 0 point for the Fahrenheit scale. At the freezing point of distilled water, that becomes 32. And of course the boiling point becomes 212. If you get right down here, it's minus 460. So these two scales are very easy because to deal with, because 1 K is equal to 1 degree C. So converting those is very, very simple. Converting these is not quite so easy. What we have is formula like that. That helps us to convert either way. So if we wanted to convert C, we can change the formula around. C equals F minus 32 times 5 over 9. Okay, don't matter about the transposition of the formula, I've done that for you. Let's put a value in. Let's say if we had minus 40, minus 32, let's say minus 40 Fahrenheit, I want to convert it to centigrade, 9 there, times 5. Minus 40, minus 32 becomes minus 72. I divide 9 into 72, that becomes 8. Okay, so we've equals to 8 times 5 over 9. Sorry, 5 8 to 40. So we've got minus 40. So minus 40 Fahrenheit is also equal to minus 40 centigrade. It's the only point where the two scales become equal, have equal values, all the rest of the time. Different ones. You don't have to do all this, of course. If you've got a smartphone, you download an app. It'll do it all for you. But if you're back to first principles, then that's a simple little formula you can do. And you can transpose this round, of course, in terms of Fahrenheit as well to get, if you know the centigrade, you can calculate. But that's what I want you to do. I'm going to give you a value to do using that formula. See if you can convert. Let's say if we had 68 degrees Fahrenheit, what would it be in the terms of, I've done it in a way so the figures are all whole numbers. Okay, so if you have,
get it wrong with that.
so there we go. There's a basic, I've changed the formula for you. Okay, I've given you, I've got 68 degrees Fahrenheit. What would it be? What would that be in centigrade? So, let me know when you've had a go.
Would that be the
166.
Yeah, that's right, yeah.
right start?
Remember, there's a thing, what we call modulus. Brackets of multiplication, division and subtraction. So you always deal with the brackets first. Okay, so
166 degrees.
I really don't know.
That's what I'm thinking.
So 68 minus 32. What's 68 minus? What's 68 minus 32?
36.
And divide 36 by 9
17 degrees.
is 68 minus 32 gives you
36.
36. Divide 36 by 9 equals,
4.
multiply 4 by 5,
20.
so 68F is equal to 20 degrees
20 degrees.
centigrade. Okay. Okay. And of course it goes the other way around. If you have centigrade, if you wanted centigrade, the basic formula CO5 equals F minus 32.9. In terms of F, it becomes F equals, so that goes up the other, doesn't it? You've got C times 9 over 5 plus the other side plus 32.
Well,
Okay.
these are your basic functional skills.
Hey?
So,
I know, I'm lacking.
Have you done?
so this other way of doing it is doubling and adding 30.
There's another one. That is a rule of thumb way of
Is
doing
that
it.
rule of thumb? It's near enough. It's not.
It's near enough. It's near enough. You can do it
Within
within
4
30
degrees.
It will do. This is exact. Okay.
Yeah.
You can do it exact that way. And of course, when you've got appliances, a lot of appliances still have got Fahrenheit on them, like cookers and any domestic appliances still refer to the Fahrenheit scale. Last summer the Americans had some very hot weather in New York, and they had temperatures of 130 degrees. And not centigrade, that was Fahrenheit. Okay, and in this country, because they latched onto that, and they started talking about big figures, that and they moved away from the Celsius. The Celsius scale is not an SI. SI, do you know what SI is? System International of Units.
Right.
Okay. The Kelvin is the SI unit. The SI unit that we use. Sorry?
15 minutes, isn't it?
15 minutes. Okay. Right. Really, the whole thing was really to give you an introduction, because most people know what temperature you're at. Every day we are affected by this value. Just get a little bit of understanding of the different scales, which sort of, this one's your normal one. Occasionally that comes in, unless you're an engineer or scientist, unlikely to get involved in the Kelvin scale at all. But it is there, it's in the background. Well, I found that useful. Thank you very much indeed. And the next subject will be we'll talk about pressure, because that's the reciprocal that you need to know about pressure as well. Okay, thank you very much.